There's one more thing that comes up when trying to name ionic compounds, and this is this idea of polyatomic ions. Polyatomic ions are a group of atoms that are so tightly bonded to each other that they act just like one ion. So this will be a group of atoms acting as if they were a single atom, a single ion. If you look at your oxidation sheet, you can look down at up at the top right, and you can see a whole list of polyatomic ions. Let's take, for example, the nitrate ion. Nitrate ion is NO3. This whole thing has a charge of -1. And early on, I'd suggest using the parentheses. It'll help you think that that -1 isn't just for the oxygen, and it isn't for the nitrogen, but it's for the whole thing. This whole group of atoms acts as if it was just one ion with a -1 charge. So let's use this idea in naming. So we're familiar with the idea of trying to hook two ions together. So suppose we were doing barium with this NO3 minus 1. This whole thing acting like a -1. So we just do the same thing we've always done. We make our scales. Cation on the left, in this case it's barium. Barium always makes a +2 oxidation number. But now on the right side we have this thing called an NO3 polyatomic ion. Its charge is a -1. Just like we would before, we need to go ahead and balance this out so that it has a neutral charge. And as we can see, ready to write down its formula, there's Ba, one atom, and again, use of parentheses, NO3, two atoms. And those parentheses are not optional. You need to do that if there's two of those. And if we smooth this out or clean it up a little bit, we would write Ba parentheses NO3 2. The name uh, is a little bit of a variation. We'd go ahead and still write barium like we've always done. But now the second part doesn't get any name change at all. So it's just nitrate, just as if you copied it right off your oxidation sheet. So barium nitrate doesn't change the ending to anything. Just stays with the same ending that it had on the sheet. One more example. Let's go ahead and say we wanted to do sodium with another polyatomic ion, carbonate. So we go down our sheet and we discover that the carbonate ion is CO3, and this whole thing acts like it's a -2 ion. So we create our scales like we always have. On the left goes sodium. Sodium always makes a +1 cation. And on the right-hand side, CO3 polyatomic ion acting as if it was a -2 in charge. Now it comes time to balance this out. You can see, oh, I need another sodium. So now there's two sodiums on the left-hand side of the scale. So we're going to write our formula. This would be sodium, two atoms, parentheses, CO3, the polyatomic ion, only one of them. And unfortunately, when they clean this up, they're going to write Na2, parentheses, CO3, and I would suggest that you leave it there for a little while, but texts are going to show this as Na2, CO3. So I fixed that up a little bit with my eraser so you could see that a little clearer. So Na2CO3, and again, the second part of that keeps its name, so you don't change any name suffixes at all. So this have a name of sodium carbonate, C-A-R-B-O-N-A-T-E, sodium carbonate. It works the other way if you're given the name. So let's suppose it's silver acetate. ACETATE is the polyatomic ion that you have to deal with. Go ahead and make your scales. Look for silver. On the sheet you can see silver always makes a +1. And then acetate is a C2H3 O2 polyatomic ion, all acting as if it's a -1, this whole thing. So again, balancing out, we're okay, +1 and -1. We can go ahead and just write the formula. Silver, 1 atom, polyatomic ion, C2H3O2, and just one of those. Again, the cleaning up, they're going to go ahead and just put silver, drop that one. They're going to drop the parentheses and put C2H3O2. When you're saying this name, it's just going to be called silver, S-I-L-V-E-R, acetate, A-C-E-T-A-T-E, silver acetate. One final example, let's say they give you the name of a aluminum carbonate. So aluminum carbonate, we're going to go ahead and make our scales. Aluminum always makes a +3. Carbonate ion, CO3, makes a -2. The whole thing acts like a -2. This is one of those that you can see the common denominator necessary, so I'm going to need another CO3 -2 on this side and another CO3 -2 on this side. And the aluminum, going to just need another Al +3 over here. Brings us to a +6 on the left, a -6 on the right. We're all balanced out, so we're going to write our formula. Al, 2 of them, parentheses, CO3, 3 of them. And there won't be any need for us to drop the parentheses here because that 3 indicates that we're going to need to keep them there. And there's no real cleaning up that needs to be done. That's the way it would be. And this would be pronounced, well, we already have it up here, aluminum carbonate. And notice that there's no changing of the suffix at all. It still stays just like it is on the sheet, aluminum carbonate.